Okay, so here we are in Visual Studio. I just added a noise suppression filter to my recording software. I think now it should be better with the background noise. The fan was slightly annoying, I think. I hope it wasn't too distracting. But yeah, let's start coding. And let's take another look at what we could start with. There's actually, I just realized that there's one very important class, another one that we need, but let's skip this in the concept for now. I will add it later. Let's actually start coding. And first of all, like I said, there was a class created with a template that derives or inherits from the game class from the MonoGame framework. And then obviously here's our starting point of the application, which will just create an instance of this game class and then call its run method. So this is basically the starting point. Yeah. Okay, so the first thing that we need to take care of is we need to load our assets so that we can use them. Normally you would have to really think about how you want to handle this, because it can be you really need to plan this out. I mean, if there's like, I know, hundreds of assets, hundreds of sound effects, hundreds of textures, then you should really think about how you should what strategy to use for loading them. Maybe only load the ones that you actually need for the current game level. Maybe each object in the game should handle the assets to load by itself, stuff like that. But in our case, we're very lucky because there's only 4 assets that we need to load. So we really don't need to think about it too much. What I would suggest is we just, upon startup of the game, we just load all of them and store them in memory. Because, yeah, it's just 1 sprite sheet and 4 sounds. There's no need to, to optimize that. We can just load all of the assets when the game starts. And this is something that we would do in the load content method, which is inherited from the game class. Here already added code for creating an instance of the sprite badge. And it added a little to-do comment here, which specifically says that you're supposed to load your content here, which is what we're going to do. And for that, we will need the content pipeline. And this is, like I said in the beginning of the tutorial, basically the only reason currently why we would still have to install the MonoGame framework using the installer wizard. It's really just to get this content pipeline application, which we don't necessarily need, but it's highly recommended. Anyway, in order to import our assets now into our game, we need to do the following. In your template, in your project, there should be a folder named content. And that's where you're supposed to put all your content. You can put them anywhere else. You can set this up like as you want, but by default it should be in the content folder. And the content folder actually contains the content pipeline application. If I open it up in the file explorer here, there is a content file in there, and if I start this up, it will start the pipeline tool. And this can be used to import and pre-process the assets for our game. And this is actually really simple. We just start it up and then go to File, or use one of the icons here. That's actually even simpler. we can say add existing item, then navigate to our assets, and add the sprite sheet here. And now it asks whether it should copy the file into the game directory or just add it as a link. We would actually want to copy it, so click add. So now, yeah, it's in the content pipeline. Now let's create, let's do that for the sounds as well. Add existing item, and I think we can even just simply select all of them. This. And yes, they should be copied. Yes, yes. And yeah, that's it. Now they're in the pipeline, and now the pipeline needs to actually build the files that our game will reference. That they're basically turned into binary files that can easily and quickly be loaded. Basically, what it does is it uses a preprocessor to serialize those specific files into instances of a certain type used by the MonoGame framework. You don't need to know the specifics behind this. It would be good if you did, because the content pipeline is actually quite powerful. You can create your own preprocessors and stuff. I usually do that when I create my games. I usually, for all of my resources, well, not all of them, but some of them, I create a preprocessor that serializes them into a usable format and stuff like that. But you don't need to do that. It's basically optimization. All of the common file types are handled perfectly fine by default by this content pipeline. So now that I added all of them, I can just hit build. And all of these green check marks indicate that everything worked fine and it built 4 files. And now I need to save this, and I can close the pipeline tool. So now what it did, it created, first of all, it added the files here, but it also created binary files for them. So here you can see, for example, Trex spritesheet.xnb, which is a binary formatted file that represents our sprite sheet, and our game can now work with these files. And in order to load these files, we just need to reference them by name. So let's store the names of these assets in some constants here in our game, so we can easily load them. So let's add a constant, a private constant of type string, and name, I don't know, asset name sprite sheet, and that would be Trex sprite sheet, and do the same thing for the sounds. And you need to specify the name without the file extension. And also it's not case sensitive. Score reached. There we go, and another one, and I would hit Control D to duplicate the line, and then I just change it up a little bit. What's it called? Button press. And there we go. And yeah, so now I have some constant values here that store the names of the assets, and I will use these constants. I will use these constants to load the files. So let's actually here create a new field for each of them. And sound effects are for sound effects, the MonoGame framework actually includes a class named sound effect. It's in a different namespace, that's why it's not found by IntelliSense yet. But if I highlight it here and go to use IntelliSense, I can say using Microsoft XNA Framework Audio, and we'll add a using directive right here. You can just add it manually by yourself. Yeah, and now it will recognize the type because I included the namespace, and I will call it SFX hit. Then do the same thing, button press, and score reached. Now we could have a separate asset manager class or something that handles this, but since we only have 4 assets, it's so simple. We're just going to have our game class handle it itself. Okay, and of course a texture 2D. I will call it spritesheet texture. Now I declared fields where I can store these objects, but I need to actually load the assets and store them in these fields, and I can do that in the load content method. So for now, let's delete this comment here, and I can load assets using the content manager class from the MonoGame framework, and actually our the game class has a property of type content manager here, and it's just called content, and I can use that to load the content. And the content manager has a property load where I can specify the type using a type parameter, and I want to load the sound effects. And now I need to specify the name, and the name will be what is stored in the constant. Button press, and of course this now then returns the sound effect that was loaded, and I want to store it in the field that I created. There we go. Duplicate it and do it for the other assets as well. Hit. Oops. This is a brand new laptop, and I kind of have to get used to the keyboard layout. It's a little larger than what I am used to. So this is why I keep screwing up. Okay. And the texture, of course, we also need to load that. Whoops. And specify the type. And there we go. This is all we need to do in order to load the assets from the content folder. What can we do next? We could prove that the texture is loaded properly by just rendering it on the screen in this draw method, for example. I could do something like sprite batch begin. Whoops. Sprite batch begin. It takes a couple optional parameters, but we don't need to pass any. And let's just, for testing purposes, render the entire sprite sheet. And yeah, there are a couple different overloads here for this method. I'm just gonna see what fits our need best. Let's pass here the sprite sheet texture and pass a position where it should be rendered. Let's just create a new vector. I don't know, 10, 10 should be fine as a position. And the color is actually, what by color they mean a tint color. And if you just pass white, it means no tint at all. So it will just be the original color. So yeah, this should be fine. Let's see. Okay, there's something wrong here. Unable to cast object of type song. Oh, I didn't know that. Apparently, okay, yeah. We imported the MP3 files. By default, we imported them as a song instead of a sound effect. So I think we need to go back into our content pipeline by just clicking here again, right click, open folder, and open the pipeline again, then highlight the sound effect here, and I think down here you can select the processor, and here it says song, but I think you can instead just say sound effect and save, and do it for the other ones as well. Sound effect and sound effect. Now, this alone doesn't solve the problem. We now need to rebuild the content. So click rebuild, and it was successful, so we should be good. Save it, close it, fine, and try again. And now it should actually work. And there we go. So now it renders the sprite sheet. Looks great. And it actually already has a proper alpha channel. I actually thought that we would have to adjust that, but looks great. So yeah, looking good. Obviously this is not what we want to render to the screen, but this was just to show you how easy it actually is in the MonoGame framework to render something to the screen. Now let's see. What do we need to do next? Okay, I just made a quick cut because I need to sort of plan what steps to do next, what would make the most sense. This is still unscripted and off the cuff and stuff. I know I keep repeating that, but yeah. If at some point I seem to be a little unorganized or lost, it's just because of that. I just really like to establish this as a series where we just create something off the cuff from scratch, just having some fun, you know, create something together, and yeah. So okay, so now we're able to draw something on the screen. Obviously we don't want to draw this entire thing here. For example, we might want to only draw this little character here, this Trex character. Let's see. Let's take a look at the sprite sheet itself in this in photo filter here, or paint or paintnet or whatever you want to use. So this one here is actually just this little idle icon or idle sprite. I think we can completely disregard this one and work with only these ones here. And let's say I want to specifically draw this sprite. It's basically just a part of a large texture. And I want to tell MonoGame that I don't want to draw the entire texture, I just want to draw this specific part. Well, we can do that. It's very simple. We can actually, in the draw method of the sprite batch, we can pass the coordinates of the part of the texture that we want to draw. And here in the photo filter, for example, it tells me the coordinates of my selection. Let's see. I think all of these are the same size, which would be handy. I hope they actually are. These ones apparently aren't, but I think all of the ones where the Trex is standing up, they're actually of the same size. So let's see. Yeah, should be good. So it says here the width is 44, and the height is 51, which is kind of a weird value. Maybe we will include another pixel down here and have it be 52. Also need to know the coordinates, and it should tell somewhere, I think it's this one. It should be the coordinate x 848 and y 0. Yeah, let's actually test this and go into MonoGame, and here in the draw method use one of the other overloads. Let's see. I haven't done this in a while. Let's see which one of these overloads. Yeah, the destination. No, it's not the destination. It should be the source rectangle. There we go. This is the one we need. So here we can pass a source rectangle, which defines yeah, the coordinates within the texture that makes up our sprite. Whoops. Ah, sorry about that. Okay, so here we need to pass an instance of rectangle, which is a struct from the MonoGame framework, and it has a couple of different constructors. One of them is really simple. It just takes the x, y, width, and height, which is perfect. So x, we said, was 848. Y should be 0, the width should be 44, and the height should be 52. Something like this. So this should be fine. So now it should theoretically only draw the Trex sprite. Let's see if it works. Perfect. This is exactly what we want. It's just perfect. Okay, great. So now we need to now we know how to isolate a specific sprite from a sprite sheet, and this is actually what I was referring to when I said there's something still missing in our concept, in our diagram. Since we will need to do this quite often, and you really shouldn't repeat yourself when you're coding, let's generalize this. Let's actually encapsulate this in a class that is specifically responsible for rendering one specific portion of a sprite sheet. So let's go into our model here again in our diagram and create a new class and call it sprite. And the sprite, as we just saw, needs a texture to work with. So we can either make it a property or a field. I'm not sure if it ever makes sense to change the texture once the sprite has been created. Probably not. Add a property. And we'll just make this setter private. Let's keep it simple. So it needs to know what texture to use, and it also obviously needs to know the coordinates. And we could use the rectangle, but I think it's a little more handy, a little more useful to actually simply set the coordinates as a point. Or we could just go integer and say x, y, width and height, which is also fine. It really doesn't matter. So let's just say x. And then an integer y, an integer width, and an integer height, and then give it a property, a method draw, which takes a sprite batch as the argument. And I think that's it. And now that we have a sprite, we know that our Trex class will need a sprite in order to be rendered. So we can say, this is getting a little messy. So we can say that our Trex has a sprite like this. And here we could add a property of type sprite, and it's just going to be named sprite, and the setter is going to be private, something like this. So now we have a class that is specifically designed to render a specific portion of a sprite atlas or sprite sheet. Yeah, let's implement this right now. And then test it. Let's get started here. Let's actually create a folder here. Add a new folder and call it, I don't know, graphics. And in this graphics folder, we will add a new class and call it sprite. There we go. We don't need to make it public, but we can. I will, just for no specific reason. Okay, so now we have our sprite class, and let's implement it just the way that we just modeled it, that we just conceptualized it. It needs to have a texture, so let's do that. And it will not recognize this type because it is in a different namespace within the MonoGame framework, and we can use IntelliSense to fix that. There's also a texture 2D in SharpDX, which is in turn used by the MonoGame framework, but we don't want to use that. We want to use the one from the MonoGame framework. So you have to use this using directive here, using Microsoft XNA framework graphics. And I know I explained this earlier in the beginning of the tutorial, but the reason why it says Microsoft XNA framework is very simple. MonoGame is really just an open source implementation of Microsoft's XNA framework, which used to be, well, a framework provided by Microsoft itself. For game development, mostly for obviously Microsoft platforms like Windows and the Xbox, and but it was discontinued at some point. But since it was really powerful and just a really good framework, people decided to take matter into their own hands and continue the support of the framework with an open source implementation that is hosted on GitHub. It's really cool, and I really support this project. It's just awesome. So yeah, it's for historic reasons. It's still called the namespace. It's still called Microsoft XNA framework. So it's basically for backwards compatibility. So just a little history lesson on the side. Okay, so we have a texture 2D property here, and now we need these integer properties, x, y, width, and height. Let's implement them. And if you're wondering how I'm doing this so quickly, I use a code snippet, which is a default code snippet that is built in with Visual Studio. Just type prop and hit tab twice, and it will stub out the public property. Yeah, this is fine. And obviously, when we create a sprite, all of these values need to be set, otherwise the sprite would not be in a valid state. So we need to have a constructor that initializes all of these values. And we can type it manually like this. Yeah, we can do it manually like this, or I could have just let me just cut this. We could have just highlighted all of these, right click, whoops, highlight all of these, right click, quick actions, generate constructor, and it does the exact same thing. I usually put my constructor beneath the property declarations like this. But you can put it anywhere within the class, obviously. So yeah, you have a constructor to initialize a new instance of sprite. Obviously, we can't create a sprite without having set all of these values because, yeah, wouldn't make sense. Yeah, but this is it. So now we need to add this draw method that takes a sprite batch. I'm not sure if it needs the game time. Not really. Yeah, this should be fine. And then all the sprite batch really does is call its draw method, and then here we pass the texture property, and oh yeah, we should also take the position as a parameter where it should where it should be rendered. Sorry. So add a parameter, an argument of type vector2, which is also in a different namespace, which is Microsoft XNA framework. There we go, and call it position. And here, yeah, pass the position, and then create a new rectangle, and this rectangle will be composed of the properties that of our sprite class itself, like this. And yeah, let's actually make it possible to pass a tint color as well. So let's add a new property here of type color, which is also included in MonoGame, and it obviously describes and encapsulates a color. Let's call it actually tint color, so it's a little less confusing, and initialize it to white, and then here pass the color, sorry, the tint color, and that's it. So now we have a reusable sprite class that we can use to specifically draw a certain portion of a sprite sheet. So we can do this now. Here, instead of this, what we can do, hold on. Here we could create a new sprite. Oops. And remember, we put it in a different namespace named graphics, so we need to reference this namespace with a using directive using Trex runner graphics. Create a new instance, and here we have to pass the values for initialization. Sprite sheet texture, and then here pass these values, coordinates, and that's fine. And then instead of this, we can simply say Trex sprite draw and pass the sprite batch and some position where we want to draw it. Let's go 2020. Something's wrong here. Oh, of course. There we go. And now it should do the exact same thing without us needing to repeat ourselves every time we want to draw a specific sprite. So now we have a class that takes care of that. So always try to follow the dry principle. Dry is an acronym for don't repeat yourself. Try to make your code as reusable as possible. Okay, so now that that is taken care of, we can now continue. So let's maybe create a folder here called entities. And first thing we need is this iGame entity interface, right? Because it's basically implemented by nearly all of our classes, so it's very important. Okay, so let's go ahead, right click here on the entities folder, add new item, and then here in this selection, select the interface, of course, and we're going to name it iGame entity. There we have our new interface type. I'm going to make it public, even though it really doesn't matter. Now, let's take a look in our class diagram here, and let's implement our interface exactly the same way as we specified here. It needs a property of type integer with a getter. Okay, so we need to add a property of type integer named draw order with a getter, and we need to add these two methods, update and draw. They both do not return anything. Now again, it will not find the game time type because it's in a different namespace, and I can just include the namespace here with a using directive using Microsoft XNA framework. There we go. You can manually add that as well. And same thing with the draw method, which will additionally take a sprite batch as an argument. There we go. And again, sprite batch is in a different namespace, so there we go. Okay, so this should be fine. And now we can implement this interface with our concrete entity types, entity classes. So yeah, obviously our Trex is one of them. So let's start with the Trex. So yeah, go to entities, add new item, class Trex. So now we have a new class named Trex. I'm going to make it public. You don't need to make it public. The default access modifier would be internal, which means it can only be, it's only visible and accessible within this assembly. But since we only have one assembly, it doesn't make a difference. But yeah, I'm just gonna make it public anyway. Okay, so now our Trex class needs to implement this interface, and we can do it like this. And now the compiler will say, hey, you promised me it wouldn't. You promised me the class would implement this interface, but it actually doesn't. It doesn't have the properties and methods defined in the interface or declared in the interface. So I can now either add these missing members myself, or I can have IntelliSense handle that by hovering over here and say implement interface, and we'll create a stub for the missing members. Actually, the draw order we can implement as a simple auto property like this. Should be fine. The draw method, we will just have these both methods do nothing for now. Okay. So obviously the Trex needs to be passed or needs to have a sprite to be rendered. So let's add a property like we did here, of type sprite. Whoops. Again, it's in a different namespace. So add a using directive using Trex runout graphics, and now it recognizes the type, and now we're good. And yeah, this should be fine. Now let's look at the diagram again. So we need a sprite, we got that taken care of. It needs a position, we don't have that yet, so let's add it. Property. Again, I'm just going to type prop and press tab twice. Vector2, which is again a type from the MonoGame framework. There we go. This is fine. Now it needs to have a state. We haven't defined the state type yet, the Trex state type. We would have to do that. So let's go ahead and do that. Whoops. Actually, let's put it here. Add new item, and you will see that enum or enumeration is not a template here. So we'll just say class, it doesn't matter, we're just going to lie and call it Trex state. And instead of class, we want to make it say public enum. And then here, list all of the different states, idle, running, and what was the other one? Idle, running, jumping, and ducking, and possibly falling. And that's fine. And let's go back into our Trex class, and here add a property of type Trex state, and name it state. And the setter should be private so that it can only be set from within this class. So the state is maintained through the appropriate methods and not by the client of whoever uses the class setting the state directly. That doesn't make any sense, and it just puts the Trex in an inconsistent or invalid state. So yeah, let's take another look here. So we got the sprite taken care of, we got the position taken care of, and the state as well. Now we need an isAlive property. Now, if you, hold on. Like I said, by typing prop, you can use the snippet for a public property with both a getter and a public getter and setter. But if you want the setter to be private, you can type prop G and then hit tab twice. There we go. And what else? Speed, of course, and it's going to be a float. Whoop. There we go. And yeah, what else? Okay, this is okay for now. We don't need to implement the jump, run, jump, duck, and whatever methods for now. But what we do need is a constructor, because if we did not define a constructor ourselves, then a default constructor will be added, which allows an instance to be created without setting any of these properties, and it doesn't really make sense because the Trex does definitely need a sprite. It doesn't work without a sprite. It definitely needs a position. So yeah, we need to initialize those. So let's add a constructor here. And pass the sprite to the constructor, as well as the, well, actually, we don't need to pass the sprite. We can just pass the texture and call it, I don't know, sprite texture, or no, call it sprite sheet. And then the position. And that should be it. And now we can use the constructor to initialize the object. And now we can just simply set the sprite using the sprite sheet and the coordinates that we know, which is x is 848, y is 0, width is 44, and 52 would be the height. And hard coding these values here in the constructor is not very clever. We should probably store them in a constant, and we can do that by, well, just defining the constant manually ourselves. Private constant int Trex default sprite pos x, I don't know, 848, and then Trex default sprite pos y is 0, and so on and so forth. But we can also simply right click the value here, 44, select quick actions and refactorings, and then say introduce constant for 44, and it will automatically stub out a constant here, and we will say Trex default sprite width, and do the same thing for the height. Trex default sprite height. So now we don't need to pass the specific sprite to the constructor. We can just simply pass the sprite sheet, and the constructor itself will take care of the rest. And obviously we need to set the position to whatever position was passed. And there we go. And actually we can already implement the draw method because it's really simple. For now, all it's going to do is actually draw the sprite by calling the draw method of the sprite and passing the sprite batch that was passed to this method. And then the position would be the position property of this Trex object. So just position. Or if you like to be explicit, I could say this position, it doesn't matter. It's the same thing. So yeah. Okay. That should be it for now. So let's test this by going back into our Trex runner game class and remove all of this. And instead, for example, for now, let's go into the load content method to test this. Actually, let's go up here and create a new field of type Trex. And obviously it's in a different namespace, which is called entities. So we need to reference this namespace with a using directive. There we go. Okay, so now we have a field of type Trex, and we can store an object of type Trex in that field, and we will initialize it and instantiate the Trex in the load content method for now, just for testing purposes, and say here Trex equals new Trex, and here we can pass the sprite sheet and a position. Again, we're going with a 2020 for testing. There we go. And then in our draw method, we can then simply say Trex draw and pass the sprite badge and the game time. And I forgot the underscore again. There we go. And now we should get the exact same result. There we go. Perfect. But now it is handled in its own class, and we can further build on this class to define the behavior and properties of our Trex. Okay, looking good so far.